A?
I can't skip it.
Yeah, conjugate, right? So we'd multiply top and bottom. Now, I'm not suggesting we should do this. We would do the square root of 23 plus h plus the square root of 23 divided by itself, right? Right, and then that's gonna give us, you know, a minus b times a plus b is a squared minus b squared. So that would give us, if we did this, the limit of a squared, which is just 23 plus h, right? Minus b squared, which is 23, over h times this stuff. As h approaches 0. And look what happens. The 23s cancel horizontally, so they add to 0. The h's, we can cancel the like factors. And then, so what are we left with? We're just left with the limit of 1 on the top over this thing on the bottom. And then if I take my limit as h goes to 0, I get 1 over the square root of 23 plus the square root of 23. Actually, that's just 2 square roots of 23. Right? Deal? Okay. But, did we have to do all that stuff? No, they just want us to calculate the limit. Well, the limit is the derivative, isn't it? Look, we can cheat now. This is legal cheating because we know if this is f of x, let's just differentiate f of x and evaluate the derivative, right? At 23. We can use our derivative. We can do it all in this little green box up here now. You know, we have our tricks. That's the same thing as x to what power? 1/2. Okay, so then f prime of x is going to be what? 1/2 x to the, okay, so isn't that just 1 over 2 radical x?
Yep.
Because x to the minus 1/2 is just a square root on the bottom. So then f prime of 23 is just 1 over 2 radical 23. Pretty quick.
That's good.
Yeah, right? Much easier. That's why we have the shortcuts, because they're so much easier to do. Okay? Okay, good. I mean, same thing here, but maybe we can just jump to an answer on this one. So we're trying to match this to, and it might be useful to write it down. We're trying to match this to the limit of f of x plus h minus f of x over h as h approaches 0. And what value are we obviously plugging in for x here?
3.
3, okay. So we're getting the limit of f of 3 plus h minus f of 3 over h as h approaches 0. Well, what must f of x be?
Nine.
9 times x squared, wouldn't it be? Right? Because look, I've got a 9 times something squared, right? Does that make sense? Okay. So this only works if f of x is 9x squared. That would work, right? Because then what would f of x plus h be? 9 times the quantity x plus h squared, right? And what would f of 3 plus h be? 9 times 3 plus h squared. But what do you know? There it is, right? Okay, so we know what a is. We know f of x is 9x squared. We know A is 3. And what would be the easiest way to do this one? Well, let's just take that derivative and evaluate it at 3, right? For part 3, if they want to know what's the value of the limit, that's just f prime of 3. Well, f prime is what? Of 9x squared? 18x, yeah. So that's just going to be 18 times 3, which is 54, right? Okay, make sense? Okay, so I am recording, so, I mean, if that, you can go back and look at that one if you want it, if you want to see that again. That might be one where it's worth, going back and taking 5 minutes and just kind of connecting all the dots. If you're not quite there right now, you're probably super close if you're not there, but one more viewing of that, you'll be fine, okay? All right, easy stuff here, graphing derivatives. We've done a lot of this. You want to take a quick look at a couple of these or not?
Yeah.
Okay. So let's just graph the derivatives in red. Okay, so what about that top one? If I want to graph the derivative function, what's the one point that I actually know the value of the derivative?
The maximum.
Okay, right here, good. At the horizontal tangent, that's going to be a value of 0, isn't it? Okay, and then what do we assume from there? It's, what's it doing? If I move this direction, the tangents become increasingly positive if I move to the left, right? To the right, they become increasingly negative. So what is the derivative function then? Well, and we're gonna always assume that this is the simplest scenario possible, that the slope is changing uniformly. Joseph, I saw you make the swish. It's gonna be like that, isn't it? It's just something like that. Do we know exactly what the slope is? No, there's no units on this, right? But it's going uniformly from some large positive slope to some large negative slope. Okay? Make sense? How about this one? This one's a little tougher, but we can do kind of the same type of thing, right? What do we know about the slopes here? As I move from left to right in this interval, what are they doing? They're going from small negative values to large negative values. Well, doesn't that look pretty much like the function there? Right? So in this part right here, I'll graph it. So in here, it's going to look something like that, right? Okay. How about the next interval? We're going from large positive to 0 is where? Like, I don't know, like right in there somewhere, right? And then what's happening? Then they're getting increasingly negative. Okay, so what's that going to look like? We're going from large positive to 0 to increasingly negative.
Gonna get like.
Yeah. Okay, so, right, so it's going to do something like this, isn't it? Large positive through 0, large negative. Okay? Okay, how about over here, this interval? We're going from large negative to less negative. So just like that. Okay. And on this one, this is, I know you might be thinking, well, how do we know exactly where it is? Well, all you're going to do is you're going to match up, you're going to pick the right graph. So only one of the choices is going to be close to that, right? Okay? Okay, how about in fact, let's just skip up. Let's just skip up to that one, kind of the same question. So in the interval from 0 to 5, what are all the values of x at which f is not continuous?
2.
Only 2, right? Everybody agree that's the only place I have to pick my pen off the board? Okay. What about all the places where the function is not differentiable?
2 and 3.
2 and 3, good, because I've got a break in the function, discontinuity, right? And remember, differentiability implies continuity. It must be continuous to be differentiable, but you could be continuous and non-differentiable like at 3, right? So that would be 2 and 3. And then what if we sketched a graph of f prime? I mean, we just did. You wanna do this? You want practice or not?
Sure,
Okay.
sure.
So we're going from, it looks like 0 up to some positive value linearly, right? So something like, I don't know, something like that. Okay, and then what about up here? Going from 0, right? Down to some fairly large negative value, right? Now, what do I put for my endpoint here? Can it be solid? Oh, I'll fill it in this way, that you will go back to that. So you tell me, what do I do for the endpoints? What about that endpoint? Can I fill it in? No, it's not differentiable, right? The derivative doesn't exist there. So I can't, the derivative is not defined at 2, so neither one of those endpoints could be solid, because the derivative doesn't exist there, and I'm graphing the derivative function. Okay, what about at 3? We're making a jump here, aren't we? We're going from some large negative value to some small, or to some constant positive value. So what's the last part of the graph gonna look like?
Just try it up there.
Somewhere up there. We could probably calculate what it is by looking at the units, but we're not gonna bother. Right? Can I fill in those endpoints? Either one of them?
No.
No, because it's not differentiable at 3. Right, so the derivative can't exist there. Okay? All right, you wanna do that one?
I figured it out eventually.
Okay, it's just a quotient rule. You just wanna go through a quotient rule and just do a little practice? Okay. So we can wrap a little bit of exponential stuff in there too. All right, so if we're calculating f prime of x, what's our quotient rule? Low d high, so I've got low d high. What's the derivative of 6e to the x? 6e to the x, right? Good. Minus high d low. What's the derivative of e to the x plus 7? E to the x plus 0, right? Divided by e to the x plus 7 squared. All I gotta do is simplify. So if I distribute the 6e to the x, what am I gonna get here on top? If I distribute that, I'm gonna get 6e to the x times e to the x is what? I get 6. E to the x times e to the x is what? What do I do if I multiply like bases? Add the exponents. So
E to the 2x.
e to the 2x. So 6 e to the 2x plus 7 times 6 is 42 e to the x minus e to the 2x divided by e to the x plus 7 squared. And so look what happens then. 6e to the 2x minus 6e to the 2x cancels, and I just end up with 42 e to the x divided by e to the x plus 7 squared. That's it. Okay? Okay, this one, this is really simple if you just take it just a second and think about this one. Do I want to use the quotient rule here?
No.
No, what do I do instead here?
Well, you divide all the terms.
Divide all the terms by x, right? I've got a monomial in the denominator. So this is one where it's easy just to divide that term by term. So we would rewrite this one as, what's x to the 6th over x?
X.
Good. What's 9x cubed over x?
X.
What's 4 over x? But that's a 4x to the, there you go. Just differentiate each term using the power rule. Much easier, right? Okay. Could you do it using a quotient rule? Yeah. It's a lot of extra work. Okay, this is another one I feel like we probably ought to take a look at. There's a lot of thinking that goes into this one. Pretty important stuff. So this one, you don't get a choice on this one. I want to go through this. In fact, I want everybody, if you're if you're kind of splitting your focus, I want you to pause that, take a time out, close them up, and look at this one. This is one I've wanted to go through with you for a while. Okay, determine a value of m, if possible, it may not be possible, for which f prime of 4 exists. Okay? So we gotta have a little discussion about this now. This is a piecewise function where the pieces the pieces are separated at the value x equals 4, right? So what are the criteria here for this derivative to exist?
The two have to be equals.
So what do you mean by the two? The two whats?
Both functions have to be continuous.
Okay, so the function must be continuous because differentiability implies continuity. Differentiability requires continuity. So it must be continuous, right? So we gotta check that. In fact, let's make a little short list here. So f must be continuous. Let's go. At x equals 4. So there's one criterion. What's the other one? I think you're going to say it. What's the other thing that has to be true about the derivatives? Okay, yeah, what would happen if the derivatives from the left and the right had different slopes? What would that look like?
It would be,
What would it be? Sharp corner, wouldn't it? Right, we'd be doing something like this where we're coming in with one slope and leaving with another one, which means we've got an instantaneous change in the slope, AKA some kind of a sharp corner, right? That's not a place where it's differentiable. So the other thing that must happen is, we got no sharp corners. How do we say that, how do we communicate that to the math gods? Because they don't really know much about like words like sharp and stuff. All they know is functions and derivatives and things. So no sharp corner.
Would be the limit of this slope.
Yeah, so the derivative from the left must equal the derivative from the right. Agreed?
yeah.
Okay? So in other words, the limit of f prime of x as x approaches 4 from the left must equal the limit of f prime of x as x approaches 4 from the right. Agreed? Okay, so let's check this stuff. Well, this one's pretty easy to check. I mean, all we got to do here is just see if this is continuous, then the limit of the function from the left has to equal the limit of the function from the right. Agreed? So for a criterion 1 to be true, this must be the case. The limit of f of x as x approaches 4 from the left must equal the limit of f of x as x approaches 4 from the right. The ants have to anticipate stepping on the same spot or there'd be a break in the function, right? Okay, so let's do that. What is the limit of f of x as x approaches 4 from the left? From the left.
Oh,
That'd be the top one, right?
Yeah. So,
So it'd be m times 4 minus 48. So 4m minus 48. What's the limit as f of x approaches 4 from the right? 3 times 4 squared, so 3 times 16 is 48.
Yeah.
Okay, so we could solve for m there, right?
Yep.
If I add 48 to both sides, 4m equals 96, so what's m? 24. Okay, so do we have our answer? Is 24 the answer?
We need to check it.
Maybe,
I was
right?
dividing in my head. I don't know if there's one of those two.
24 is the answer if 24 makes criterion 2 true also. But if it doesn't, then the answer would be it's not possible. There is no one. Okay? So we got to check criterion 2 with 24. So if we do that, now let's calculate our derivative function here first. What's f prime of x? If f of x is mx minus 48 for the top piece and 3x squared for the bottom piece, what's the derivative of f of x? M on the top, right, when x is less than 4. And what is it down here?
6x.
It's 6x when x is greater than 4. And the question is, what is it when x equals 4, right? does it exist or not? Okay, so we'll check. Well, we know what M, and M needs to be 24, right?
Yeah.
So we get f prime of 4, well, I'll just do it this way. F prime of x would equal, I'll do f prime of 4, I'll do that. I'm not. It's not going to be good. I want to do this.
Yeah.
I want to do my limit, okay? So I'm going to take a picture of that. I don't want to write all that stuff. Excuse to play with my toys.
With all of that? With all of that, or
Okay, so let's try
what?
this.
Should we do this?
So there's our derivative function. The limit of f prime of x as x approaches 4 from the left is m, right? Does that equal the limit of f of x as x approaches 4 from the right? Or what do we get? As I'm approaching 4 from the right, I'm getting 6 times 4. And what do you know? It works. 24 is the value that works, isn't it? When we plug 24 in, we get 24 equals 24, which is true. So it satisfies this other criterion, and 24 is the answer. Okay, everybody get that? Okay, that's a pretty good question. There's a lot of stuff that goes into that. Okay, a couple more, and then we'll have a little car twister thing. So if we've got this composition of functions, and you guys can decide if you want to hang in here for this one or not. So this isn't really calculus. This is just a review of some critical pre-calculus stuff. We've got this composition of 3 functions. H of x is f of g of x. And they're telling us here, we want to calculate h prime of 8, right? So where f and g are differentiable on their domains, and they're telling us g of 8 is 9 and g prime of 8 is 7. So what else do we need to know to calculate h prime of 8? So if I want to calculate h prime of 8, how am I going to do h prime? Now we've only talked about this one time, but what's the extended, well, actually we talked about this quite a bit. We didn't do this exact example, but you can do this. So what is h prime of x if h of x is f of g of x? By the chain rule.
F of g of x times.
So it's with the outer layer is f, right? F of
Yeah.
hand. So I'm going to get f prime of hand okay, times what's inside, derivative of what's inside, which is g. Oh, that's only 2 layers. We'll mostly say 3. There we go. Okay. So if I'm doing h prime of x then, or h prime of 8, what's that going to look like? H prime of 8 is going to look like f prime of g of 8 times g prime of 8. Okay? Well, what is g of 8? They tell us g of 8 is 9,
Yeah.
right? So this is equivalent to saying f prime of 9 times g prime of 8. Well, what did they give us? They gave us
G prime of 8.
They gave us g prime of 8, which we needed, and they gave us g of 8. But what did they not give us? F prime of 9. So what we would need is that guy, right? F prime of 9. Make sense? Okay. So just kind of a conceptual question dealing with chain rule stuff. So what about this one? If I want to calculate h prime of 3, same kind of thing. If I want to calculate h prime of 3, and h is defined as f of g of x, what is h prime of 3? F prime of
G of
G is
g of 3 times
G
g prime of 3. Well, do we know that stuff? Let's see. G of 3 is 4. Okay, so that's equal to f prime of 4 times g prime of 3. F prime of 4 is -5. G prime of 3 is 7/8. So we get an answer, right? Okay, how about down here? P is g of f of x, so p prime of 2 is going to be g prime of f of 2 times f prime of 2. Well, what's f of 2? F of 2 is 2, so that's going to be the same thing as g prime of 2 times f prime of 2, and they give us that stuff, right? So we could do that, okay? What are we at here? 25. 25. Do you want to? Well, I'm only a couple minutes. Might as well see if we get one more. Free up some time for you to walk. Okay, another just composition kind of question. So if q of x is sine to the 5th of 6x minus 1, and we want to write that as a composition of f of g of h of x, what's the outside function here? The outermost layer of this is what? No. Because if I rewrote this, it's written with shorthand, but if I rewrote this without using shorthand, what about that exponent? What does sine to the 5th of something mean?
5.
It means sine of all of it.
Okay, it means the sine function taken to the 5th. It's just awkward to write that, right? So that's really the same thing as saying sine of 6x minus 1 to the 5th. So now I ask you again, what's the outside function? What's f? It's hand to the 5th, right? Okay? So f of x has to be x to the 5th. What's the next level in? What's g of x? Sine of hand. Okay, so g of x would be sine of x. And then finally, the inside function is h. What's that? If I look completely inside, I've just got a 6x minus 1. Okay, so what is that? Is that right there, right?
Yeah.
Okay. So you want to do this? I mean, what would we do with this one? Well, what's my u and what's my v?
U squared minus.
Okay, so that whole
6x
thing,
plus 6.
this whole thing is u. And that part is v, and this is just a product rule, isn't it? Right? So y prime is just going to be u, so 3x squared minus 6x plus 6 times dv, which is e to the x, plus or minus? Plus.
Plus
6x minus 6.
6x times the derivative of u, which is 6x minus 6. I've just distributed that. Right?